As we delve into giving Claude the tools to check its own work, it's important to know exactly what skills and understanding you'll gain from our time together. We're going to empower you with powerful new habits and techniques for your AI-assisted workflow. Let's begin by looking at your first key takeaway. First, you'll develop a clear understanding of why automated verification isn't just a good practice, but truly the most impactful habit you can adopt in your AI-assisted coding workflows. This insight will empower you to make smarter decisions about your process from the start. Next, we'll get practical. You'll learn precisely how to instruct Claude to run automated checks after it makes changes. You'll also become skilled at interpreting the results, ensuring you always know what those checks are communicating. Building on that, you'll be able to clearly distinguish the operational differences between feedback loops that include automated verification and those that don't. This will help you fully appreciate the significant shifts in efficiency and reliability that verification brings. Then we'll guide you in seamlessly integrating automated verification into your daily workflow, specifically by leveraging a project's Claude.md rules. This practical application will make it easy for you to adopt these powerful techniques immediately. Finally, you'll learn how to adapt your verification strategies effectively for projects. Whether they have a robust testing infrastructure or are just starting out, you'll gain the flexibility to apply these powerful techniques in any development environment you encounter. While adapting verification strategies for different projects is certainly a key skill, the fundamental truth is AI-assisted coding is that it looks right is never enough. This principle is especially critical when you're working with advanced models like Claude. Let's delve into why Claude benefits so much from a structured verification process. You'll discover that Claude excels at describing its intentions, giving you a clear picture of what it aims to achieve with its code. However, its strength lies in generating and explaining, not in inherently verifying the actual functional results of that code. You might find that Claude's confidence can sometimes be misleading. Code that sounds perfectly right or logically flawless can still contain subtle breaks. These are the kinds of hidden issues that are incredibly difficult for you to catch through manual review alone. This is precisely where automated verification steps in to bridge that critical gap. It provides a robust mechanism, allowing the code to prove its own functionality before it ever reaches your final review. This is the shopping cart project we'll be using for this module. Notice the clear product list on the left and the cart sidebar on the right, which is currently empty. Let's begin by adding the mechanical keyboard to your cart. Observe how its details, including the unit price and total for the item, immediately appear in the cart sidebar. Next, we'll add the USB-C hub. You'll see it appear as a new line item in your cart, and the overall total updates instantly to reflect this addition. Watch closely as we add the USB-C hub multiple times. Instead of creating new entries, the quantity for this item increments, demonstrating how the cart manages duplicates and updates the running total per item. Finally, let's add the monitor stand to complete our initial selection. Notice how the total price for all items in the cart updates one last time. This interactive demonstration highlights the basic functionality of adding items to your cart and sets the stage for our deeper dive into automated verification within this project. Let's begin by opening our shopping cart project in the terminal and establishing a clean Git baseline. We'll initialize the repository and all our starter files and commit them as our initial state. Now let's run the existing test suite and confirm everything passes before we make any changes. Great, 10 tests, all green. This is our verified baseline. Any changes Claude makes from this point forward should maintain this state or improve it. If any test goes red, we'll know immediately what broke and exactly what caused it. Now let's open Claude Code in our project directory to begin a new task. We instruct Claude to add a discount system to the cart, applying 10% for orders over $100, displaying both original and discounted totals. Crucially, Claude will run its own tests and only commit if they pass. Claude immediately begins processing the request, starting its thought process to understand the task and the project. Claude dives into the project structure, searching for relevant buttons and carefully reading files like app.jsx and app.test.jsx to thoroughly understand the existing code. It then proceeds to read the cart CSS and products data, analyzing cars.module.css and products.js to gather all necessary context for the task. After reviewing the tests, Claude proposes an update to cars.jsx to include the original total, discount amount, and final total, ensuring existing tests remain compatible. Claude presents the proposed changes for cars.jsx for your review, waiting for your approval to proceed with the edit. Next, Claude proposes the necessary CSS styles to cars.module.css to properly display the new discount elements, ensuring a consistent visual presentation. With the code and styles updated, Claude initiates the test run. Claude runs the tests and confirms all 10 pass. With successful verification, it proceeds to sage the changes and prepare for commitment. Claude sages the modified cars.jsx and cars.module.css files, requesting your approval before adding them to the Git staging area. Before finalizing, Claude requests approval to commit the verified changes to the repository with a descriptive message. The commit is successful. Claude confirms all tests passed and provides a concise summary of the updates made to cars.jsx and cars.module.css. Claude details how the footer now displays original, discounts, and final totals for orders over $100, while orders under $100 remain visually unchanged. It also highlights the easy-to-find discount constants. Finally, Claude provides insights into test compatibility, explaining how existing tests still pass because the expected value appears twice in the DOM, showcasing its thorough understanding of the rendering process. Let's test our new discount feature. Watch as a second mechanical keyboard is added to the cart, automatically triggering the 10% discount for orders over $100. Notice the new original and discount lines appear along with the updated total. Finally, the USB-C hub is added to the cart, and you can see the cart totals recalculate to include this new item. The discount is applied to the overall total. The cart now accurately reflects all added products, their individual prices, and the correctly applied discount. You can see the final total displayed clearly. We just saw how powerful it is when Claude can check its own work, autonomously finding and fixing errors. But what does the process look like when automated verification isn't part of the workflow? This alternative feedback loop is often slow, manual, and prone to error. Let's walk through what happens when Claude can't verify its own output. Without automated verification, Claude finishes a task and simply describes its output, asserting it should work based on its internal model. It's confident, but that confidence isn't backed by concrete execution. Next, you, the developer, review the proposed changes, perhaps run the application manually to visually check, and then commit the code. This is where the gap in verification begins. Much later, the problem is often discovered, not by Claude, but by you or a user encountering an issue in the live application. This requires significant manual debugging to pinpoint the root cause. Once you've identified the issue, you must return to Claude and painstakingly explain exactly what went wrong and where. This requires your detailed analysis and careful communication. Only then does Claude attempt a fix, and if that fix doesn't entirely resolve the problem, the entire cycle repeats. This can become an exhausting, iterative process until the issue is finally squashed. We've just seen how this autonomous correction cycle plays out, where Claude fixes and verifies its own work. Now let's visualize this remarkably faster, automated, and robust feedback loop that you get when integrating verification. It all begins when Claude completes its initial coding task. As Claude is in the process of writing code, it's not just completing the task, but immediately running the test suite right after, as you instructed. This crucial step ensures that its work is checked without delay, setting the stage for true automation. If tests fail, leading to a problem being discovered, Claude sees the error output directly and instantly. There is no need for you to intervene, read the results, or feed them back, streamlining the entire discovery process. This direct feedback allows Claude to swiftly move to diagnose and fix the issue. It analyzes the failed tests, pinpoints the root cause of the problem, and then intelligently implements a correction. Once a fix is in place, Claude doesn't wait. It immediately re-verifies by running the tests again. This iteration continues autonomously until all checks pass green, confirming the issue is fully resolved. Finally, once all tests are green, you reach the stage where you review and accept the changes. You can confidently review them, knowing they are already verified and functional, and accept them with complete peace of mind. Running npm run tests once is certainly useful, but making it automatic is far better. One powerful way to achieve this is by adding a rule to your project's Claude.md file, as you see here. This rule now tells Claude to automatically run the tests after every relevant change without you having to explicitly ask it each time. The instruction becomes part of the project's persistence context, not just a one-off prompt, making verification a non-negotiable part of your workflow. You might be thinking, what if your project doesn't have a comprehensive test suite to run automatically? That's a valid concern, but you can absolutely still implement verification because any structured check is better than none. Let's explore some powerful options, starting with the gold standard. As we've discussed, npm run test remains the gold standard for automated verification. It's incredibly effective at catching logical errors and ensuring your code behaves exactly as you expect it to, proving correctness beyond just it looks right. For projects using compiled languages, npm run build offers excellent verification. This command will catch any type errors or compilation failures before your code even has a chance to run, providing a crucial layer of early feedback. Beyond functional correctness, npm run lint is highly valuable for static analysis. It helps you maintain high code quality and consistency by catching stylistic issues and potential pitfalls that might not break functionality but can lead to problems later. Even if you have no dedicated tests, npm run dev can serve as a minimum acceptable form of verification. Running your development server will immediately surface any catastrophic runtime crashes or critical console errors, giving you essential early feedback when changes are made. Following our practical demonstration of committing verified changes is a great moment to consolidate everything we've explored in this module. You've gained invaluable insights into making your AI-assisted workflows much more robust and efficient. Let's recap the core takeaways, starting with the immense power of verification. Automated checks fundamentally alter the feedback loop, with Claude autonomously handling much of the error correction, increasing your efficiency and code reliability. We covered how to instruct Claude to run npm run tests after its changes and interpret the output for immediate feedback. You saw firsthand how Claude self-corrected issues by directly observing test failures, presenting you with verified work. Beyond one-off instructions, you've now integrated npm run tests permanently into your Claude.md file. Finally, you're now equipped to confidently implement verification in almost any project's context, using commands like build, lint, or dev to ensure baseline quality even without a full test suite. Welcome. By the end of this session, you'll gain some truly powerful skills that will transform your debugging process. We're going to dive deep into making your interactions with Claude incredibly efficient and effective. Let's start by looking at our first goal. First, you'll be able to clearly explain why simply pasting raw error output is always faster and more effective than trying to describe a bug in your own words. You'll understand the core reasons this approach saves you so much time and frustration. Next, you'll learn to master a fantastic technique, using exclamation mark commands to directly feed terminal outputs into Claude's context. This will streamline your workflow and ensure Claude always has the precise information it needs to help you. Then we'll guide you on how to save a clean, efficient debugging workflow as a reusable skill. Imagine building a personal toolkit of effective strategies that you can deploy again and again. Finally, you will complete the full discover, save, and reuse loop across 2 sessions, making your entire debugging process incredibly efficient and systematic. You'll build a habit of continuous improvement that will serve you well in all your projects. The project we're using for this lecture is a weather dashboard. On the surface, it looks straightforward, a search bar, a weather card, a city not found message, but this project has 4 real bugs seeded into it, the kind of mistakes a developer might actually make. Our job in this lecture is to find them, fix them, and turn the debugging workflow into a reusable skill. Alright, so we have our weather dashboard projects ready. To prepare for the upcoming bug fixes, we've set up version control. This involved initializing a new Git repository and making an initial commit of this starter code, establishing our baseline. To open the project in the browser and see what we're dealing with, let's start by running the npm run dev command in the terminal. As you can see, the Vice development server quickly initializes and provides a local URL for our application. However, when we check the browser, you'll notice a syntax error that prevents the app from starting at all, which is our first bug. Now let's also check the test suite to understand the full scope of this problem. We'll stop the current development server and proceed to execute the npm run test command. As the tests run, you'll observe that they also fail due to the very same syntax error we encountered earlier. This means the problem is foundational to the codebase, and we'll start by fixing this initial bug. Let's fix the syntax error in temperatureutils.js. To fix this, we'll copy the raw error output directly from the terminal. This provides Claude with all the necessary details, from the file and line number to the nature of the problem. After clearing the terminal, we'll open Claude Code to get assistance. This is the key habit. Instead of describing the error, we paste the raw output. We paste the copied error output into Claude and simply add the word fix. The detailed error message gives Claude all the context it needs to diagnose the issue. Claude immediately begins composing a response, analyzing the error details to understand the problem. Claude reads the file, identifies two bugs. A syntax error where a parenthesis is enclosed, and a logical error with the Celsius to Fahrenheit conversion formula. Claude then proposes a fix, showing us a clear diff. It addresses both the enclosed parentheses and corrects the Fahrenheit conversion multiplier from 1.5 to 1.8. With the fixes applied, Claude confirms that the syntax is now correct and the conversion logic is accurate. The app should now compile and reload without issues. To verify our changes, let's run the tests. We instruct Claude to execute npm run test. Claude confirms the command to run the test suite. Once executed, we see that all tests pass, confirming our fixes have resolved the underlying issues. Now that our tests are passing, let's commit these changes. Claude will choose a suitable commit message. Claude first runs git status to understand the current state of our repository. It then checks the git diff to see the exact file changes, followed by git log to review the recent commit history. Claude uses this comprehensive git information to formulate an accurate and descriptive commit message for our bug fix. Claude proposes the exact git add and git commit commands, complete with a detailed commit message outlining the syntax and formula fixes, then confirms the commit. The commit is successful, and Claude confirms that one file was changed to correct the Celsius to Fahrenheit syntax and formula. We see the final commit message has been applied successfully. You can see that the app loads now with no errors. Try searching for London in the app. Every valid city returns city not found. This is bug 3. Something is wrong with how the app looks up cities in the data. We'll copy-paste the error text into Claude. Here we combine the raw console output with a very brief description of the symptom. This gives Claude maximum context with minimal human interpretation. Adding more context to help Claude understand the problem, searching for London returns city not found. We are asking Claude to fix this. Claude begins analyzing the issue, looking for the relevant search logic in the codebase and identifying areas of concern. Claude executes commands to locate where city search logic is implemented. It displays the find command it's using, which then starts running. Next, Claude initiates a grep command to search within the identified files, which begins executing. Claude quickly reads the relevant files, searchbar.jsx, weatherdata.js, and app.jsx. The analysis is complete, and Claude reads one more file to gather additional context. Claude pinpointed the exact spec. Keys are lowercase, but the lookup calls to uppercase, preventing any match. It proposes to switch to uppercase to lowercase for city name lookup. Once I confirm the edit, the change is applied. Claude confirms that searching for London with any casing will now correctly match. With the bug resolved, let's commit these changes. Claude begins the commit process, drafting the commit message. It displays the git commands it will use to inspect the changes before committing, reviews the diff, and prepares the full commit message. Let's confirm the commit. The commit is successful and Claude finalizes it, confirming the new commit hash. Let's check the app in the browser to see if the fix is working. We rerun the search and just like that, London's weather is displaying correctly. Bug 3 is now fixed and the city search functionality works as expected. The city search functionality now correctly handles different casing. However, a crucial step is missing, a test case to prevent this case insensitivity bug from ever returning undetected. Let's add one. Claude begins by examining an existing test file, temperatureutils.test.js, to understand the current testing patterns and structure. Claude continues its analysis by searching for relevant test patterns within the file to inform the creation of our new tests. It then displays the contents of the temperatureutils.test.js file, reviewing the existing test code for guidance. Claude continues processing the information, determining the best approach for the new test file. It proposes creating a new test file, weatherdata.test.js, alongside the weatherdata.js file for logical organization. Claude presents a comprehensive test suite for get weather by city, including tests for lowercase, title case, and uppercase city names, and also for unknown cities. Claude has successfully written the 20 lines of test code to weatherdata.test.js, establishing robust validation for the city lookup. Before running the tests, Claude asks for our approval to execute the npm run test command. Upon approval, the tests begin running, and we see the Vitess test runner executing, indicating the tests are in progress. Claude confirms that all 5 tests passed, highlighting that the new case variation tests are crucial for immediately catching any regression. To manually verify the test execution and output, we run npm run test directly in the terminal. The test executes successfully, confirming both the temperature utils and weather data test files passed, with all 5 tests running as expected. With all tests passing and ensuring the bug is fully covered, we prepare to commit these new test files. Claude drafts a concise and descriptive commit message to document the addition of the new test suite. It displays the git add and git commit commands along with the full commit message detailing the new case insensitive city lookup tests. The commit is successful, creating a new commit that formally includes the new test coverage. Let's open the temperatureutils.js file. I'm going to reintroduce bug 2 by changing the multiplier back to 1.5. It looks like Claude fixed it while fixing the 2 bugs we fixed so far. Let's stage and commit this change with a clear message indicating the reintroduction of bug 2. Back to the Claude terminal. Let's run npm run test directly within Claude Code to execute your tests and capture the output. Immediately, a failing test appears, highlighting an incorrect Celsius to Fahrenheit conversion in the temperature utils file. To address the issue, you ask Claude to fix the failing test. Claude analyzes the error, identifies that the conversion formula uses an incorrect multiplier, and proposes a direct code change in temperatureutils.js to correct it. After you approve the proposed code change, Claude automatically applies the fix and reruns the test suite. You see all 5 tests now passing, confirming that the temperature conversion bug has been successfully resolved. With the test passing, you can instruct Claude to commit this change. Claude prepares a descriptive git commit message detailing the fix to the temperature conversion formula, then stages the file and successfully commits the change to your repository. We just followed a clean, repeatable debugging pattern. Paste the error, fix it, run the test with the exclamation mark, fix what's failing, verify in the browser. That pattern works on any project. Let's save it. Claude intelligently analyzes the previous turns in the conversation to understand the workflow we just completed, and it writes that workflow into a new skill file. Now commit. This ensures our work is saved and the skill is part of the project's version control. Our last bug to fix is the wind speed displayed in kilometers per hour instead of miles per hour. Let's prove the skill works. Clear the session to simulate coming back tomorrow with a fresh context. New session. Instead of building the debugging workflow from scratch, we invoke the skill. One prompt. Claude immediately begins to follow the full workflow defined in the skill. It starts by locating the problem, reading relevant source files like weathercard.jsx and weatherdata.js to understand the context. Claude then identifies that wind speed is displayed in kilometers per hour and needs to be converted to miles per hour. It creates a new utility file, windutils.js, to handle this conversion. Next, it integrates this new conversion utility into weathercard.jsx, updating the display to show wind speed in miles per hour. After implementing the fix, Claude automatically runs the test suite to verify that nothing broke. With the fix implemented, we can instruct Claude to commit the changes. Claude reviews the git status and diff, confirming the modifications to weathercard.jsx and the new windutils.js. Claude then stages the modified files and proposes a commit message. These changes are successfully committed, updating two files. We've now seen how powerful it is to turn a debugging workflow into a reusable skill, letting Claude handle the repeatable steps while you make the high-level decisions. This entire process can be broken down into 3 simple stages. Let's start by thinking about how you first develop a useful workflow. First, you discover a debugging workflow that works for your projects, like the one we just used to fix those 4 bugs. This involves clearly pasting the raw error, using the exclamation mark to capture test output, and then fixing and verifying your solution. This initial discovery phase is where you build your effective pattern. Once you've perfected that debugging workflow and made it clean and repeatable, the next step is to save it. You achieve this with just 1 prompt, and Claude intelligently writes the skill file for you, ready to be committed to your project. This solidifies your hard-won expertise into a tangible asset. Finally, and perhaps most powerfully, you reuse your skill whenever a similar bug appears. In any future session, you simply invoke the skill by its name and the entire workflow executes consistently and efficiently. This means solving new problems without ever having to rebuild the process from scratch.
Thanks for watching. If you like this, you'll love Zenva Academy. 300 courses where you learn AI by building real apps. Links in the description.